See, if you got a budget and you can do these, this is the molecules. The kids are making these. They know what it looks like. You got a double bonded oxygen, single bond, single bond. We've got a nitric acid. Okay, there's nitric acid, nitrous acid. How do you get the difference? NO2 with that proton. See, now we're balanced out. Now we can hang right and know that all this is kosher. All the bonds on the nitrogen, double, single electron pair, single bond of that oxygen. This fills the octet here with 2 lone pairs on the green. So this gives the spatial dimensions for what this molecule looks like. This is nitrous acid. You've got a hydrogen that can come off, so now you've got radical stuff happening in the atmosphere. This is why this is such a reactive pollutant. The nitrogens being so electronegative, these guys want to be by themselves. You think they want little brother hanging along here? Well, they don't. So they forms ions, it forms radicals, hydrogen comes and goes. Nitrous acid, proton on the oxygen. Nitric acid, 3 oxygens on the nitrogen, the proton on the oxygen. HNO3. So a lot of times you kids are memorizing these acids. There's only 1 proton for nitric acid. So it's a strong acid because, like I said, these are electronegative. So they stick together. They'll ionize this real easy. They'll give up that proton, not even care. So now you've got NO3 minus 1. Sulfuric acid had 2 protons, remember? Strong acid, it gives them both up. But nitric acid only has 1 proton, but this is the strongest acid. This will etch gold. I had some young foreign women, let's just say, really rich at the community college, and I was TAing the lab. That girl was spilling nitric acid all over her fingers with like a $35,000 gold wedding ring. I was afraid her husband was going to come and nitric acid all over their hands, turns it green and stuff. But I thought, man, the gold, that thing's gold plated and it wears it off, and she finds out he forged her ring, I'll get in trouble. So nitric acid, professors, is this teaching them something? Come on, look how I'm doing this here even. We got a double bond here. How are we going to get HNO3? Oxygens are so beautiful in this respect because wherever there's a lone pair of electrons, that's going to be the double bond to the oxygen. And now out here is where the proton is, to keep it true to color. Oh, we'll draw it H. So this is H, N, O, 3, nitric acid. You can do this with the balloons. Again, I'm low budget. One of these days I'll be able to afford better balloons and pieces of Velcro. But this is cool. This is a learning experience. I love this. I can't get enough of it. I got to tell you. And if you do this with the half-filled helium, I'm not going to waste the helium here either because we're still in the sad state. Can you read this on the board? Does it show very well here? Show on the bottom. We're going to write this here. This is the C-Star Memorial Lecture. C-Star died this morning from lack of medical care, from lack of my money being able to get her transfusion when she needed it last Tuesday. She finally got one Saturday, $500 I'm out. I still got an open wound in my mouth. John Orchard, you frickin' idiot, the worst dentist I've ever seen. Starts a root canal, doesn't even tell me. 4 hours I'm in a dentist chair, my back's killing me. I don't know what the heck's he doing. C-Star, 7th of June, 2010, 10:23 in the morning. Rest in peace. International Space Dog, man. She was a hit everywhere she went. Santa Maria, you got the devil on your back. I'm out of here. Okay, we forgot a couple here. Carbon. Forgot all about the carbon one. CO2, CO. Leave the C star thing there. Rub it anyway. N2s are out of here. Now we're doing carbon. Unburned hydrocarbon. What we should probably do first is photosynthesis. Okay? Everything on my chair here. I'm doing this on the fly because we just rearranged everything. We forgot about carbon. Double bond. I get one on there. See, I knew that would happen. Get this down here. There we go. We got more electrons. We ran out of electrons. So we're going to get one and the complementary one, okay? And we're going to put one of each on the other side. Carbon is 4. Remember the diamond? These are pins here. Oh, we're going to get black. Carbon's a diamond. Black diamonds. That's carbon. Okay. Carbon does 1, 2, 3, 4 bonds. So if we have H, 4 H's. Methane, CH4. We get, let's say, keep this color coded right. Might as well draw this up here. I cannot emphasize this enough. These triangles are the best way to learn chemistry. Oxygen, double bonds. 4 on the carbon, this is CO2. Here's a triple bond with a lone pair of electrons on the carbon is C with 3 bonds, 2 and O. Draw the electrons in there. Carbon monoxide. Carbon monoxide, carbon dioxide. So when we look here, we got carbon. We had 4 H's, would be methane. We've got our oxygens here. Oh, these are too far apart. Too close or too far? See, that's the alien, though. See the lone pair of electrons on the nitrogen? Although this is carbon, but that's what nitrogen would look like, right? Okay, so we've got double bonds on carbon, and we need another oxygen over there. Come on. And it's going to be on the other side now, because remember, it's like magnets. Magnets attract each other, they repel each other. So this is what a CO2 would look like. Carbon, it'd be perfectly straight across. 2 double bonds, double bond, carbon dioxide. In the air, you know, it's vibrating. But with the double bonds, this is going to stay bound. Now you've got a carbon oxygen triple bond, carbon monoxide. So again, if you do the sticker thing, you can see the carbon's going to have a lone pair of electrons out there. It's going to be totally opposite this side. So this is carbon monoxide.